Okay, so here we are, an introduction to programming with Python. And then this is our second lesson. Now, we had previously learned how to make a comment and how to structure our code a little bit, and also how to do simple calculations. Now, one of the most important calculations that we'll want to do in scientific programming is calculating, say, the values of a function and then outputting it on a graph, and that's going to be our syllabus for today. Now, remember the numerical Python library, NumPy. It's got lots of useful functions in it. There's another library of plotting routines, and that is matplotlib. Now, there's a sub-library there called Python plot that I like to use. And then again, just as an abbreviation, let's just call that PLT in my subsequent code. Now, the pyplot isn't normally necessary, but I'm going to use a command called subplots that is only found in pyplot. You'll see another code that I write, it's just matplotlib, and then that's fine, but I need the .pyplot sub-library today. So to set up our graphing here. First of all, we need the domain. We're going to set a set of x values over which we're going to plot the function. And you'll notice here I'm making a couple of comments. Good structured programming so that somebody who looks at this knows what I'm doing. So because these are just x values, I'm going to call them variable x. And then in the NumPy library, there's a great command called the arange command, spell it properly, that is just going to set up a list of x values from a start value. Let's just go from -3 to an end value, 3, and let's go in steps of 0.2. So this is just going to be filling a list with this set of x values. It's actually, the last value is going to be 2.8, so it doesn't go to 3. So if I want it to go to 3, I can go, 3.01, and now it'll include x equals 3 in the list. If I leave it just as 3, it'll actually stop at 2.8. All right, so there's my list of x values. Now for each one of those x values, I want to calculate a corresponding y value. Let's just graph, say, the absolute value function. Now that is found in the NumPy library, and the syntax is just ABS for absolute value function. And then if I say y is the absolute value of x, that's the function I want to graph. But the really neat thing here is that Python is quite clever, and it knows that this x stands for a whole list of x values. So what it'll do is it'll calculate the y for each of those x values. You could put in any function you wanted there. You could do like 2 times x squared minus 3 times cosine of x. Whoops, misspelled cosine. Oh, but I'd have to say it's in the NumPy library for cosine. There we go. Minus, who knows, the NumPy library ln of x to the power of x. You could type in all sorts of nasty functions there. We'll just do the absolute value, okay? So I've now calculated all the y values for my corresponding x, and I could simply output those. I could just say print all the x values and all the y values, but that's going to be not a very nice way to display it. A graph is a much better way to do so. And to set up the graph, first of all, we've got to tell Python to make a figure. So let's say, okay, this is going to be figure 1, and I'm going to entitle the graph, I'm going to call it graph 1, and then in my matplotlib, I'm going to use the subplots command. And to start with, this syntax is going to look really strange, but I'm just telling it that basically there's only one graph that I'm outputting here. So now Python's all ready to make the graph for me. I'm going to format it a little bit. So the figure 1 contains a graph, which is graph 1. And now for graph 1, I'm going to use the set underscore title command to give it a title. So it'll just print out absolute value on the top of this graph. The other thing I might want to do is to label the x and y axes. So on graph 1, I'm going to set underscore x label. So this will be my x-axis label. So I'll just call it x. That's not very imaginative, but it'll do. Whoops, forgot the extra quote. And then my graph 1 I can set as well the y label. Oh, it's supposed to be set underscore. Sorry, set y label as y. And typically what you'll do is you'll just cut and paste this from program to program. I've included the syntax here in the comment statement. Okay, so that should set up the graph. And so we've told Python to make a figure with one graph in it. We're calling it graph 1. Graph 1 now has a title and 2 labeled axes. And simply we want to just plot x and y points. So the syntax for that, again, it's in the comment there, just so I remember how to do it. On graph 1, we're going to plot x comma y, and I'll just use dots for that. So within a quote, I just hit a period and then close the quote. And so that's going to plot, again, Python's very clever, it's going to plot all the corresponding x values and y values. And then the last thing you need to do, just ignore that for now, get rid of that, is output the graph. And there's a command in Matplotlib library that just says show this plot. Okay, so we'll save it, and then we'll hit the run command. Oh, and I've misspelled x label. Did you notice that about here? So that's why it's giving me that error. So I'll save it again. You do need to save it before you run it, so that it's running the most recent set of code. So now hit the run tab, and oh, look at that beautiful graph. That's just something I did earlier. Ignore that. It's the absolute value graph. And there you see all the little dots I used. You might want to say, notice what happens if we change the symbol. I said period. Okay, well, let's just make a little X maybe, and then save it and run it. And now the graph predictably has little X's as the marker. And you can adjust the size of the marker if you decide that that marker is too small. Let's say marker size is 7. Make it bigger. So you can play around with that a little bit. Now these are probably going to be, yeah, you see they've grown a little bit bigger there. A little easier for tired eyes to see. Okay, now let's just close up these plots, otherwise they start to fill up my screen. Now there's some other things you could do there. You can actually have 2 traces on the same graph. So we're doing the absolute value of x, and one thing we do in high school mathematics is we do transformations. So let's look at maybe 3 times the absolute value function of x. Now, what I could do then is I could say, okay, I've plotted x versus y, so I've got the absolute value graph, and now maybe on the same graph, on graph 1, I will also plot x with the y2 function, which is 3 times the absolute value of x. And to tell them apart, maybe I'll make this guy periods. And then, so the plot isn't too garish, I'm going to reduce the marker size back to the default. Okay, so now, on the same plot, I'm going to have 2 traces, absolute value of x and 3 absolute value of x. Run it, and there you go. Oh, and look, it changed the color for me to make it nice and clear. So this is 3 absolute value of x and absolute value of x displayed on the same trace. Now, in the graph statement, you can, just like in the print statement, you can put a mathematical expression here. So if you knew that you wanted to do 3 times the absolute value of x, you don't need to actually waste an extra line of code here. You could just copy and paste that in like that. Okay, the other thing you could do is you could just say, well, that's 3 times y, and you could put 3 times y in there. So Python's very flexible. It's probably better programming practice to make the function statement and then to graph it, because this looks a little ugly and is hard to read, but it certainly will work. You see, you get the same graph we had earlier. Now there's going to be some times where you're going to want to have maybe the graphs, the traces not on top of each other, but side by side. And that's where the subplots command really comes into its own. Let's go back and see how you would do that. First of all, let's paste my second statement back in here, my y2 function, okay? And let's say I want to do a side-by-side plot of y and y2, not on top of each other. So, here we are once again. So figure 1, graph 1. So now there's going to be 2 graphs on figure 1. There's going to be graph 1 and graph 2. 2 sets of axes. And you could put them one on top of each other, but let's say we want to do them side by side. So that means the two plots will appear in one row and two columns. They'll be side by side. Okay, so this is setting up graph 1. We're going to also need to set up graph 2. So let's just copy and then paste that in. So we're now setting up, you see on my figure I've got graph 1 and graph 2. They're in one row and two columns. Here's the setup for graph 1. Now I have to do the setup for graph 2. So I'll set its title, I'll label its x and y axes, and then I'll make this absolute value times 3. Okay, and now we'll plot the points. So on graph 1, we're going to plot x versus y. Now on graph 2, I'm going to plot x versus y2. And this should save it and run it, produce the plots side by side. And there they are. Now, because the y-axes have sort of scaled differently, this is maybe not the best way to display it. It was better when you could see the absolute value was making this sort of trace down here. You could more clearly compare the functions. But nonetheless, we now have them side by side. We could make them one on top of the other very easily just by saying in 2 rows and 1 column. And now they appear like that. And there are commands where you can scale the y-axis, force the y-axis scale to be the same, but those aren't really important at this stage. So what we've learned here is the arange command to set up a nice domain, how we can just type in any function we're looking for, and then how we can use some simple syntax to set up a graph, either a single one or several graphs on the same figure, to get a visual representation of that function. At the end, if I didn't emphasize it earlier, you need to put this show command to actually output the graphs onto your screen. And that's all there is to it. Graphing with Python. It's really fast, easy, and you can get some great visuals for any function that is of interest.